Alright, Falcons, today we're here to talk about the chain rule and how we can use it to take the derivative of a function. So, first of all, the chain rule, the definition, it says if f of x equals h of g of x, then the derivative of f of x is h prime of x of g of x times the derivative of g of x. So basically, if we put this into simple terms, is basically we take the derivative of the outside, leaving the inside alone, and then we multiply that times the derivative of the inside. So the first problem we have here says f of x equals the quantity 2x to the third minus 5x and its quantity squared, and we want to take the derivative of that. So let's see if we can. Well, first of all, we have the inside function and the outside function. The inside function is everything right here. That's inside the parentheses. That's the inside function. The outside function is the fact that it's squared. So what I'm going to do is I'm going to take the derivative of the outside, which means the 2 is going to come out front. And what we're going to do here is leave the inside alone. So it's still 2x to the third minus 5x. I'm not going to change that at all. The exponent is going to decrease by 1 power, so it was 2. It's now going to become 1, so I'll write 1 just to show you. But then we're going to multiply that times the derivative of the inside. The derivative of the inside is 2x cubed minus 5x, so if I, well, that's what it is, so if I take the derivative of that, we're going to get times 6x squared. The way I got that was 3 times 2 is 6, and then the exponent decreases by 1, x squared, and then the derivative of negative 5x is negative 5, so negative 5. And then if I just put it all together, we could say the derivative of the function was 2 times 2x cubed minus 5x times 6x squared minus 5. Now we could take the time to multiply that all out using FOIL or the box method, but in this case that is the derivative. That's good enough for us right now. The examples people tend to have a hard time with sometimes are when trig is involved. So I have this one right here. F of x is the tangent cubed of 4x. So we're going to do the same thing here. The way we get started is the exponent is going to decrease by 1 after we bring it out front, and it becomes a coefficient. So it's going to be 3 tangent squared of 4x. But then that's just the derivative of the outside, leaving the inside alone. What I also need to do is take the derivative of the inside. So what is the derivative of tangent? Well, that's secant squared. So we're going to multiply it by secant squared of 4x. The only thing we haven't done here, though, is the inside function here is 4x. The derivative of 4x is 4. So that's everything I need to multiply together if I want to find the derivative correctly. So we get 3 tangent squared of 4x times secant squared of 4x times 4. If I multiply the 4 and the 3, we get 12. And then we can just put these guys together here. Tangent squared of 4x and secant squared of 4x. So there we go. That would be our derivative for that particular problem. All right, for your work that you guys are going to be turning in when you get back from Christmas break, which is rapidly approaching, I have one more problem for you. It's right up here. So it says, if f of x equals sine squared of x plus tangent squared of x plus cosine squared of x, find the derivative of x. All right, I know you guys are going to be able to do that really well, and hope you guys are finishing off the break strong and having a good time. All right, talk to you later.